Hi, greetings from Kiboto. We are here to share how to control the composition of a Stable Diffusion rendered image using ComfyUI. Our end goal is to generate an image such as this one with an aspect ratio of 2:1 while having the topic of the image in the left side in order not to collide with the UI elements on the right side. In order to make it interesting, we're going to render it in a theme of our next calendar event, which is the Chinese New Year. Let's dig in. Our first step in ComfyUI is to set the width and height parameters for our efficient loader. In order to do so, we'll use this cheat sheet and we'll find the aspect ratio of 0.5, not 2.0, because in this cheat sheet, the height is divided by width and not vice versa. So for our width parameter, we'll use the value of 1408, and for our height parameter, we'll use 704. Then we'll link the efficient loader to our case sampler and load our LoRa. We assume that we already have a pre-trained LoRa for our character in order to use this efficient loader. For now, we'll keep the strength values at their default, which is quite high, 1.0, and we'll address that in a few moments. Next, we'll input the positive and negative prompts for our efficient loader. However, the positive prompt, since it changes quite a lot, will take it out to a separate text component and link it to a positive input parameter in our efficient loader. This is the first attempt to render an image, and we have two main issues with the output. The first issue is that the character is positioned in the center of the image, so it doesn't work well with our UI layout. And the second issue, which is quite difficult here to see, is that our LoRa is severely leaking to the entire rendered image, and we can see that the characters in the background are a little bit froggish. In order to attempt to fix it, we're going to reduce the strength of the LoRa from 1 to 0.75 and make another rendering attempt. Don't expect too much. So we can see that in the second image, the characters in the background are not froggish, while in the first one, they still suffer from the same phenomenon, but still the character is positioned in the middle, therefore we cannot use it with our UI. So let's get to work. The component that we need to add is an IPAdapter, and it will be used as a proxy between our efficient loader and case sampler. We'll plug in the SDXL model to our IPAdapter input parameter, and then we'll add a clip vision component, which basically takes an inspirational image as an input and translate it into a detailed prompt, textual prompt to be used for our rendering process. The image that we'll use as an inspiration is an image of our character, the frog. By the way, this image is part of our training dataset with which we trained our frog LoRa. Therefore, we can drastically reduce the strength of the LoRa parameters in the efficient loader and still expect quite a precise result of the rendered character in the final output. So we're reducing it from 0.75 to 0.5. And a little mistake here, we're changing the clip vision to use an SD 1.5. I know it's quite odd. We're using SDXL here, but if you want the detailed explanation of it, just find the corresponding link in the description below. So our third rendering attempt, and it's a total fiasco. What happened here is that our inspirational image took over our entire rendering output. We'll get to the reason for that in a second, but before that, we'll change the noise parameter for our IPAdapter from 0.3 to 0.1 because we are dealing with a transparent inspirational image here. And then for the missing part, we are adding an attention mask to our IPAdapter. As you can see, this is the final input parameter here. So we're loading a blank image, just a white background. The only requirement from that image is to be with the same aspect ratio as our rendering output. Then we're going to link that image as an attention mask and take it into a mask editor where we'll draw the exact position where we want our character to be rendered. Okay, our fourth rendering attempt, and the result is quite well. We can see that our character is positioned almost exactly where we intended. We still want a certain level of freedom for our generation process because this way we can expect more creative results. So not always the positioning of our character will be precise. As we also noticed, the characters in the background are not suffering from the same froggish phenomenon. Therefore, our LoRa is not leaking anymore because we defined exactly where we want our frog to be rendered. Okay, the only problem that we still need to address here is the gold component in our positive prompt. We can see that the gold is leaking all over the place, and we can see gold for instance, in the second image, covering almost the entire background of our character. So we're going to use the same trick all over again, and we're adding another IPAdapter component, which will use a chest full of gold as our inspiration image. So this IPAdapter becomes another step, also a proxy in our rendering process between efficient loader and K-sampler. And we are connecting the same model component and the same clip vision component, but we're loading a different image to be used as our inspiration. As we said, a chest full of gold will be used now. So we're linking this image to our new IPAdapter under the image input, and the missing piece, of course, is the mask that will determine where this chest of gold should be rendered. So we're rendering it in a new position and linking this attention mask to our new IPAdapter. So here's our fifth rendering attempt, and as you can see, this is a success. That's exactly what we aimed for: a precise position for our character, precise position for our chest full of gold. Of course, it's not perfect. There is much more to be done. We need to work around with different weights and other parameters, but in terms of controlling the composition, we are there.